So far, I mean, this chapter here, we've been mainly focused on quadrilaterals. We've been mainly focused on four-sided figures. It's kind of our main topic of discussion. Now, the first thing we really talked about was parallelograms. And parallelograms were four-sided figures with what? Two sets of parallel lines. So if a four-sided figure had two sets of parallel lines, it is a parallelogram. Or if a quadrilateral had opposite angles that were congruent, or opposite sides that were congruent, then it was a parallelogram. Now from here we talked about rhombus, rectangles, and squares. And we talked about the different properties of those this week. Properties of rectangles, properties of rhombuses, and properties of squares, and kind of how they interrelate to each other. And we talked about that a square is a rhombus or a rectangle or a parallelogram. A square is any of them, but a rhombus cannot be a square. A square can be a rhombus, a square can be a rectangle, but a rectangle can't be a square, and a rhombus cannot be a square. So, those are the ones that we've talked about so far. Now, the ones that we're going to cover today and start covering today and we'll cover tomorrow are kites and trapezoids. Now, kites and trapezoids are quadrilaterals because, well, a quadrilateral is what? Four sides. That's all it has. That's the only property of a quadrilateral. And both of these here are going to have four sides. But we cannot classify them as a parallelogram because they do not have what? Two sets of parallel sides. Because the main contingency for it to be a parallelogram is that it has two sets of parallel sides. These do not. Now, when you did the vocab sheet, there were some of these definitions that came up. One of them was base angles. And that's really dealing with this here. Now, in a trapezoid, we will have two bases. And the bases of a trapezoid are going to be parallel. They're going to be parallel to each other. So trapezoids will only have one set of parallel sides. That's what makes them a trapezoid. Now, there's two types of trapezoids that we'll come across. One is what we're going to call it a trapezoid. The other is going to be an isosceles trapezoid. Now, most likely from the definitions in the vocab, you already know what that is. But isosceles, we covered that with triangles, didn't we? An isosceles triangle had what? Two congruent sides, because if it was isosceles, it had two congruent sides. If it was scalene, it had 0. And if it was equilateral, it had 3. Now, this here isosceles trapezoid has two congruent sides. So if it's an isosceles trapezoid, the non-parallel sides, or what they're going to call the bases, are going to be congruent. And isosceles trapezoids are going to have some properties that are going to be nice that we'll cover. And it will hold true as well for trapezoids, but isosceles make it special. Now the base angles, so the two bases, the sides that are parallel, the angles that are a part of those sides are going to be called base angles. And then the legs are the non-parallel sides. Now you already have these down. We're going to look at these one at a time, these theorems. If a trapezoid is isosceles, so the two sides, the two non-parallel sides, the legs, are congruent, then each pair of base angles is congruent. So the base angles are going to be congruent if it's an isosceles trapezoid. So if it's an isosceles trapezoid, the base angles are congruent. They're going to be the same. Our next one, isosceles trapezoid base angle converse. If a trapezoid has a pair of congruent base angles, then it's isosceles. So that's just the same theorem. So if we have base angles that are congruent, then it's isosceles trapezoid. If it's an isosceles trapezoid, then the base angles are congruent. And the last theorem that we have here, isosceles trapezoid diagonal theorem. A trapezoid is isosceles if and only if its diagonals are congruent. So these properties here really are only addressing isosceles trapezoids. Isosceles trapezoids. Because if they're isosceles, these hold true. Or they can tell us if it is isosceles. Now, one of the big things with this here, and there's other factors to trapezoids, and we'll look at them with this problem, and we'll see how these work, deal kind of more with the parallel lines. Now, the stone above the arch in the diagram is an isosceles trapezoid, so the sides are going to be congruent. The legs are going to be congruent to each other. The legs are going to be congruent to each other. Turn those off so you can see a little bit better. Now, looking at this here, isosceles trapezoid, since we know it's an isosceles trapezoid, we know that the base angles are what? The base angles are congruent. Because it's an isosceles trapezoid, the base angles are congruent. So we know that the measure of angle L is 85 degrees. Hopefully I had the pin that writes. And we want to find the measure of angle K, measure of angle M, and the measure of angle J. Looking at these here, is there any one of those in particular that we can say for certainty what it is already? K, what is K? 85, because the base angles are congruent, yes? What does that mean about the other two angles? They're going to be the same, right? Because they are base angles. Now the question is, how do we get to the measure of angle M or J? Is there anything we know or kind of learn that would help us get there? 360. Yes. Because what we can say is that all four of these angles, because this one here is 85, well, we can call these other two x and x, yes? So all four of these angles add together to be 360. So what we could say is that x plus 85 plus 85 equals 360. Well, x plus x is 2x. 85 plus 85 is going to be 170. What can we do from here? We would subtract 170 from both sides. These would cancel, giving me 2x is equal to 0, 9, 1. And last but not least, we would divide both sides by 2, telling us x is equal to 95 degrees. I'll scroll back up a little bit. So we know that any quadrilateral, the sum of the interior angles of a quadrilateral is 360. Four-sided figure, sum of the interior angles is 360. On a different note, what's the sum of the exterior angles? Sum of the exterior angles of any polygon is 360. It doesn't change. Sum of the exterior angles is always 360. But sum of the interior angles for a four-sided figure is 360. We set them equal to, so x plus 85 plus 85, because we know the sum of all the interior angles is 360. And the two that we're missing are the same because it's an isosceles trapezoid. We set up our equation, x plus 85 plus 85 equals 360, and solved and found the missing angles are both 95 and 95 degrees. Any questions on this here? We good with this here so far? Yes? Okay. Apparently I'm just going to mark on the board. All right, let's look at this one here. So we want to find the missing angles, and we know that angle A is 42 degrees. We also know that it's an isosceles trapezoid. So what other angles do we know? What is D? 42. Because the base angles are congruent, yes? Okay. Where can we go from here? Yes, we could do that. Let's do something different this time. Now, consecutive interior angles were two angles that were between what? Parallel lines and were cut by a transversal. And what did we know about consecutive interior angles? They had some special property to them, and they weren't congruent. They add up to something. It's not 360. It would be 180, right? Because we went over that. We had two lines cut by a transversal, so the two angles that were on the same side of the transversal and between the lines added up to be 180. Well, wait a minute. Is C and D on the same side of parallel line, inside parallel lines, and on the same side of a line? So what do we know about angle C and angle D? They add up to be 180, yes? So 42 plus x is equal to 180. And 42 cancel. And 180 minus 42, I believe will give us 138, yes? What does that mean the measure of angle B is? 138. I mean, if we wanted to check it, what I could do is take 138 plus 138 plus 42 plus 42 and add these together. Well, 2 and 8 makes 10. 2 and 8 makes 10, so we carry the 2. 4, 8, 9, 10. So carry 1 and 6. So it's 0, 6, 1, 2, 3. That's 360, yes? Well, wait a minute. Could we have used that on the last one? So let's see here. So 85 and 95. Well, what is 85 plus 95? Well, 5 plus 5 is 0, carry the 1. 9, 10, and, wait a minute. Yeah, that have to be 180. Yes. Yes, we could. Now let's look at this one here. So looking at this here, are there any angles? Find all the possible missing angles. Are there any angles that we know for sure? Well, we know S is 65, yes? What about P? Is it? Because the base angles are congruent if what? If it's an isosceles trapezoid. Is this isosceles trapezoid? Well, if we knew the diagonals were congruent, then we could say it was. If we knew two sets of sides, the legs were congruent, or the base angles, but since we don't know any of that, we can't say that P is 65 because it's not isosceles. But what do we know? That 65 and angle R do what? They add up to be 180. They add up to be 180. At 65 degrees, well, it'd be nice to have a pen, plus our missing angle equals 180. So to solve for this missing angle, well, the first thing we can do is what? We can subtract 65 from both sides, because 65 minus 65 will cancel out, leaving us with x is equal to 115. So the measure of angle R is 115. Now, can I find the other two angles from here? Well, I know that P and Q add up to be 180, yes? And that all four of them add up to be 360, yes? How many different combinations of two numbers can I have that would equal 180? So if I called this y and z, how many combinations of y plus z equals 180 can I have? Well, y and z could be any values, yes? Yeah, we could, and we would get 180. So the sum of those two would be 180, yes? Is there anything restricting the values of what those two angles can be? Well, no, they can be anything, right? So the number of possible answers I could have for y and z is, well, infinite, because y could be 1 and z could be 179, yes? We can't find y and z because we don't have enough information about what y or z is. They could be equal, because it could be 90 and 90, or it could be 89 and 91. Well, we could, because we know what r is. Because if I knew what q was, yes, then we could go from there. Because then we'd have something that this would restrict it to. Minus these both from 180? R and Q from 180? Well, that would work if they were between parallel lines. Are they between parallel lines? No, for this here, our trapezoid, these here are our parallel lines. RS and PQ are not parallel. Right. But it works out, unless we have something for one of these two here, there's no way for us to continue. This is as far as we can go. Yep. Yeah, this is it. Because we don't have enough information to say exactly what Q or P is, the angles themselves, beyond the fact that they add together to be 180. So this is the only angle we can actually find. Let's look at this one here. So they gave us that angle C is 60 degrees. Are there any angles that we know for sure? F is what? 60. Why do I know that? Because it's isosceles. Because those two sides are congruent, the base angles are going to be congruent as well. So what can we do to find angle D or angle E? Because that angle plus 60 is equal to 180. And if we subtract 60 from both sides, 60 minus 60 is 0, giving us x by itself. And 180 minus 60 is 120. So the measure of angle D is 120. The measure of angle E is 120. And this works because it's an isosceles trapezoid, because the base angles are congruent. So we can actually find all four. And it's not isosceles and we just have a trapezoid, we need to know at least two of the angles, yes. Yes. We need to know at least two of the base angles for us to be able to find all four. Any other questions on this here? Find all the possible missing angles. So they told us one of the angles is 70 degrees. So what can we go from there? Where can we go from there? Is? These are going to be 70 degrees. Now, and yes, we can subtract 70 from 180 because 70 minus 70 is. So our two missing angles are 110. Any questions on any of this here? Any questions on anything we've done thus far? Are we good with all this here? Yes? Okay. If the measure of HEF, so the whole angle, this whole angle is 70 degrees, and FGH, this whole angle is 110 degrees, is FGH isosceles. Is this trapezoid an isosceles trapezoid? Okay. Why not? So let's just assume it was. So if I assume this was isosceles, what would we say was true? Is that angle F would be what? 70, and angle H would be? It would also mean that these angles here add up to be what? So what is 70 plus 110? So could we say that it's true? But yes, we can. Now this isn't the exact way to do it. Let's do it a different way. Because they told us that this angle is 70 and this angle is 110, yes? So let's go to a more mathematical approach, because we just kind of filled in and assumed that it was, and hey, it worked out, it was, yes? Now, the one thing we do know about trapezoids is that the angles here between the parallel lines add up to be what? 180, yes? So if I take 180 and subtract 110, what do I get? Well, 70 degrees, yes? So that tells me angle F is 70 degrees. If I do a similar thing with the other side, I will find that this angle is 110 degrees. So are the base angles congruent? Well, yes. And one of the first theorems we had for today is if in a trapezoid the base angles are congruent, then it is isosceles. Since we're able to show that the base angles are congruent, we can say this is isosceles. And it's mainly because the base angles are congruent to each other. Any other questions on this here? Okay. If EG is equal to FH, is the trapezoid isosceles? Is it isosceles? So I'd look back at our sheet, our theorem sheet that we had, because it's on the first page. Because EG and FH are diagonals. They connect two non-consecutive vertices. So what does 7.16 say, theorem 7.16? A trapezoid is isosceles if and only if what? So for this figure here, are the diagonals congruent? Yes. So is it isosceles? Yeah. Mm-hmm. Yes, because I believe it's our diagonal isosceles theorem, or isosceles trapezoid diagonal theorem, or isosceles trapezoid diagonal theorem. Zoid. states that this would be isosceles. So it's isosceles if the diagonals are congruent. If the diagonals are congruent, then it is isosceles. It works in either direction. Any questions on this here? Okay. So we're going to work with the diagonals here a little bit. So if Km, the diagonal Km is 22, find the length of JL. What would the length of JL be? Why is that? Because it's isosceles, yes? And the diagonals in an isosceles trapezoid are congruent. So since one of them is 22, the other has to be 22. So what would we do for this one here? EG would be 8.7. Because the diagonals are congruent to each other. I mean, we could have it be a little bit more, quote unquote, challenging. Oh, no. And the only thing that would make it, again, as I say, quote unquote, challenging, is that we said something along the lines that DF is 3x minus 7 and EG is 2x plus 15, find the value of x. But this isn't, that wouldn't be any different than what we did yesterday with the diagonals of a rectangle, because again, the two measures are the same. So we would set those equations equal to each other and find the value of x. So most of this here, and again, that's why I said quote unquote challenging, is it's not so much that it's making it harder, because the overall process is that the diagonals are congruent, they're the same. And if they gave us a term with x, we just set them equal to each other and solve. And then they can make it even more challenging. No. And say instead of just finding x, we just find the length. Which isn't, again, isn't really making it, it's just adding steps. Because once we find the value of x, we have to plug it back in. The mid-segment theorem for a trapezoid. The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So what that means for us is that the sum of the two bases, the length of A, B, and DC, if we add them together and divide it by 2, or kind of multiply it by 1/2, we'll get the length of the midsegment. So the length of the midsegment, MN, is equal to 1/2 the sum of the bases. The length of the midsegment is equal to 1/2 the sum of the two bases. And it's also in the middle. So the midpoints are these here. Yes. So the midsegment for this here, MN, is equal to 1/2 the sum of the bases. Well, one of the bases is PQ, and the other base is SR. So we add the two bases together and multiply them by 1/2 to get the midsegment. Well, for us here, they told us what the two bases are. One of the bases is what? 12, and the other is? And now what? Well, we can just solve, right? Can I plug 1/2 parentheses 12 plus 28 close parentheses in a calculator? I mean, they're all numbers, so we could just plug that in and get the answer. Well, 12 plus 28 would give me 40. And 1/2 of 40 is 20. 20. So the mid-segment for this trapezoid is 20. Will the value of the mid-segment ever be bigger than the biggest side? Well, no. Will it ever be smaller than the smallest side? No. The mid-segment's length will always be between the two values. It's actually half of the two values. It's in the middle. It's the mid-segment. Any questions on this here? Are we good with this here? Yes? Let's look at this one here. So we're trying to find the mid-segment again, yes? So the mid-segment, well, they called it MN again, is going to equal what? Half of? What do we put over here? Because the mid-segment is going to be equal to half of the two bases. One of the bases is 13.5. The other is 18.9. Now we can add these two together. 4, carry the 1. 9, 2, carry the 1. And I believe if you add 13.5 and 18.9, you should get 32.4. Would you all agree with that? Yes? When he gets back. And if we multiply that by 1/2 or divide it by 2, we should get that the answer is 16.2. 16.2. Do we agree with that there? Yes? Any questions on this here? Any questions on any of this here so far? Not too bad? So what would we need to do for this one here to find the missing length? Well, we can call AB X. X is equal to what? Yes. Because the mid-segment for AB is equal to half of the sum of the bases, so 9 and 13. Well, 9 plus 13 would give us 22. And 1/2 times 22, or 22 divided by 2, would give us 11. So the length of the mid-segment for this here is 11. Questions on this here? We like this here so far? Yes? Mm-hmm. Let's look at this one. We're going to skip that one because I think we're getting the hang of this because we add the two bases together and multiply it by 1/2 or divide it by 2. Ooh. We're wanting to find the value of X because that's what we're wanting to do for this one here. What's different about this one? Well, they gave us the mid-segment, yes? So we know what? 29 is equal to what? Half of 11x plus 2 plus what? The sum of the two bases still, yes? I get a highlighter. Because 23 was one of our bases. 11x plus 2 was one of our bases. So even though they changed what it looked like, or kind of what the numbers were, we still do the exact same thing. We still have the mid-segment, which is 29, is equal to 1/2 of the sum of the bases. And that's what we have here, yes? Okay, now we need to solve for the value of x, yes? We can do that, yes. Let's do that first. 2 plus 23. So we have 11x plus 2 and 23. Since they're on the same side of the equal sign, we can just combine them because they're like terms. Now, if I wanted to try to move it from one side to the other, then we would subtract. Then we would do our subtraction. Right, I need to times it by 1/2, yes? I'm kind of dividing each number by 2, yes? Will 11 and 25 divide by 2 evenly? No. I don't even have to pull. I have a feeling most of us don't like dealing with decimals if we can avoid it. Yes? So, if you remember back to last semester where we talked about mid-segments of a triangle, where it's equal to 1/2 of the base, or if it didn't divide by evenly, we could multiply both sides by what? 2. Because really, when we multiply by 1/2, we're really doing what? We're dividing everything by 2. So if I multiply both sides by 2, well, 2 times 1/2 is what? 1. 2 times 1/2 is going to be 1. And what that's going to leave us with is 11x plus 25. Because we could have multiplied everything inside the parentheses by 1/2 and got the correct answer, got the same answer. But it's going to make it a little bit easier if we multiply both sides by 2. Well, 2 times 29, if we plug that in a calculator, will give us 58. Now what can we? Yeah, now we can. Now we can subtract 25 from both sides. Yes. And when we subtract 25 from both sides, well, 25 minus 25 is 0. 58 minus 25 is 33. And then we divide by 11, which tells us x is equal to what? And that's all we were looking for. Questions on this here? Okay. So really the only real tricky thing in this was that multiplication of 2. Multiplying by 1/2 or dividing those by 2 wouldn't have changed anything. We would have just gotten decimals, and all the decimals would have worked their way back out. Okay? Let's look at a few more of these here and kind of go the other direction. These are going to be easier than what we just did. Huh? This here's the last one. I think there might be one or two more. Yes, sir.
Don't we plug it in back?
We can, yes. Let's plug it back in. Because if we plug this back in, 11 times 3 is 33, and 33 plus 2 is 35. Yeah. And again, we would plug it back in depending on the directions. And it's been too long since I put these slides together because I can't remember if it asked for it or not. So if it does ask for it, we would plug it back in. If it doesn't, we're just finding that value. Any other questions on this here? Okay. So let's look at this one here. Now this one here might be a little bit easier than what we just did because we don't have 11x plus 2. We just have one of the bases missing, yes? So we can just call this x. Now the mid-segment is 19. So what we're saying is 19 is equal to what? Mm-hmm. Could I have written that as x plus 13? Yeah, it's the same thing. Now, on the onset, what do I know the value of x, this side should not be smaller than? 19. Yes, it's going to be bigger than 19. Okay. That's kind of nice to know ahead of time. Now, what can we do first? Well, we can multiply by 1/2, yes? But what did we do on the last one with this pesky 1/2? We can multiply both sides by 2. Because 2 times 1/2 is 1, yes? Because anytime I don't want to have to multiply through parentheses by a fraction, I don't want to deal with that, I multiply it by its reciprocal. Because 2 times 1/2 will simplify to 1, which will leave me with 13 plus x. That's nicer to deal with, nicer to work with, yes? Than 1/2 times 13 and 1/2 of x. Now 2 times 19 would be 38. Now what do we do? We would subtract 13 from both sides. And when we subtract 13 from both sides, we get x is equal to. Are we good with x being 25? That's bigger than 19. That side length is bigger than 19. Questions on this here? Any questions on any of this here so far? We're good with this here? All right, we're going to end there, mainly because we're going to run out of time. If you want, because this here would be 5.5 is equal to 1/2 of x plus 4.4. I'm just going to run through this real quick. Because if we were doing it, we would multiply both sides by 2, because these will cancel, giving me x is equal to here. 5.5 times 2 would be 11. And if we subtract it from both sides, we would get x is equal to 6, 5. It would tell us that x is 6.6. So we would do the same method. I jumped through it because, again, we've got like less than a minute before the bell. But that's it. That's all we're covering so far with trapezoids. Okay? Now, tomorrow we will cover